In the 1930s, B.F. Skinner designed a box. Inside, a pigeon would peck a disc to receive a food pellet. When the pellet arrived after every single peck, the pigeon pecked at a steady, unremarkable rate. But then Skinner changed the rules. The food became unpredictable. Maybe a pellet would come after 3 pecks, then 10, then 2. The pigeon's behavior transformed. It began pecking manically, obsessively, far more than when the reward was guaranteed. This isn't just about pigeons. This mechanism, the variable ratio reinforcement schedule, is a fundamental engine of behavior. Deep inside your midbrain lies a cluster of neurons called the ventral tegmental area, or VTA. These neurons produce dopamine and send it forward into a region called the nucleus accumbens. For decades, dopamine was misunderstood as the molecule of pleasure. It's not. It's the molecule of anticipation. It doesn't fire most intensely when you receive a reward. It fires in expectation of a potential reward. It's the neurochemical engine of wanting, not the sensation of having. It drives you to seek, to explore, to act. It's what gets the pigeon to keep pecking. Your brain is a prediction machine. When a reward is predictable, like a weekly paycheck, the dopamine spike happens before you get it, in anticipation. The reward itself is expected, so it brings your dopamine levels back to baseline. But when the outcome is uncertain, there's no predictable cue for that anticipatory spike. Instead, if the outcome is better than expected, a surprise message from a friend, an unexpected like, your brain registers a positive reward prediction error. This error signal triggers a massive retroactive dopamine burst. The surprise isn't just nice, it's a powerful learning signal telling your brain, whatever you just did, do it again. Now, picture a slot machine. The act of pulling the lever is the peck. The spinning reels are the manufactured anticipation. The potential for a jackpot, however slim, is the variable reward that keeps people pulling. The chimes and flashing lights that accompany a win are sensory feedback that amplifies the reward prediction error. Every social media platform is a slot machine. The pull to refresh gesture, invented by Lauren Breiter, was explicitly designed to feel like pulling a slot machine's lever. Each pull is a gamble. It could reveal nothing, or it could reveal that piece of social validation you were craving. This comparison isn't a metaphor. It's a neurological reality. Functional MRI scans show that the same neural pathways, the mesolimbic dopamine pathway, are activated in the brains of pathological gamblers and in people compulsively using social media. The brain doesn't distinguish between the source of the variable reward. Whether it's the spinning reels in a casino or the endlessly refreshing feed on a screen, the underlying circuit being hijacked is identical. Your brain processes the digital like using the same hardware it uses for a monetary win or a dose of an addictive substance. The wanting system is engaged, and it doesn't care about the context. For most of human history, information and interaction had natural stopping points. A book has a final page. A conversation comes to an end. A newspaper is finite. These are called stopping cues, and they give your brain a clear signal to disengage and move on. The invention of the infinite scroll deliberately and systematically removes every single one of these cues. There is no bottom of the page. There is no conclusion. The feed is a task that can never be completed, which can trigger something called the Zeigarnik effect, our tendency to experience intrusive thoughts about an objective that was once pursued and left incomplete. As you scroll, Your prefrontal cortex, the part of your brain responsible for executive functions like impulse control and decision-making, is constantly working. It has to evaluate every new piece of information. Is this interesting? Is this a threat? Should I click this? Should I stop now? This fire hose of micro-decisions is exhausting. As your prefrontal cortex fatigues, its ability to regulate the more primitive, dopamine-driven parts of your brain weakens. The urge to just keep scrolling becomes harder and harder to resist. The very design of the feed depletes the mental resources you need to log off, creating a feedback loop where the longer you scroll, the harder it is to stop. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.